All right, so let's clear our mind and let's go on to the next FRQ. Looks like an accumulation, F prime graph analysis type question. So they're giving me the graph of F is defined on the closed interval from -2 to 8 and satisfies F of 2 is equal to 1. So they're not giving me a rule, they're giving me an actual value at a point. It's still going to be an accumulation. We have the closed interval from -2 to 8. The graph of F prime is given to us. So 2 line segments, semicircle. Does F have a relative minimum, a relative maximum, or neither at x is equal to 6? Give a reason for your answer. First things first. This is F prime, right? So there's no rule that we have to do FTC part 2 on, which is good. And if you look, F prime of 6 is 0, right? It is 0, but it's not changing signs. So you don't even need to say much here. You just need to state that it has neither a relative min or a relative max, and you're just stating because F prime doesn't change sign at x equal to 6. That's it. Don't overthink this. And again, in the past or on other FRQs, sometimes they don't give you a starting value for your accumulations. What they do is they give you a rule, and that's where FTC part 2 comes into play, and you got to be careful. All right. F has neither, use their words, a relative maximum nor a relative minimum or I'm sorry, yeah, minimum, sorry, at x equals 6 because F prime doesn't change sign at x equals 6. Good to go. On what open intervals, if any, is the graph of F concave down? Well, we know, and again, you should know doing your F prime graph analysis, that F will be concave down when what they give you as F prime is decreasing. So that's decreasing from -2 to 0 and from what, 4 to 6. Now be careful, it says on what open intervals. So you're not going to close that left endpoint down. So just read carefully. Use their words. I just say F is concave down when F prime is decreasing. This occurs, they use the word on, I'll use the words on also. On, again, if it was the closed interval, we would close down that left endpoint, but it says open intervals. So we'll go to -2 to 0. That's when F prime's decreasing. Union 4 to 6. Pretty straightforward. Find the value of the limit as x approaches 2 of that quotient, or show that it does not exist. So my thought is I'm going to start from scratch. I'll just rewrite, and I'll show you why. All right. Golden rule of a limit is you substitute in first. See what form it's in. Is it in a determinate form? Is it an actual real value? Let's see what happens. So 6 times f of 6, or f of 2, sorry. Well, there's a reason they gave me f of 2 up here. Just always be on top of your game. So that's 6 times 1 is 6. Remember, we're plugging in 2. Minus 3 times 2 is 6. All over what? 4 minus 10 plus 6. So that gives me 0 over 0. That's an indeterminate form, so I'm going to let them know that I'm doing L'Hopital's. And to do L'Hopital's, I'm going to take the limit as x approaches 2 of what? 6 times f prime of x minus 3 all over 2x minus 5. So I'm just going to apply L'Hopital's, derivative of the top separately from the derivative of the bottom. Now I can substitute, so that's 6 times f prime of 2. So f prime of 2, it looks to me as 0. Minus 3 all over what? 4 minus 5, which gives me a negative 3 all over a negative 1, which is equal to 3. So that's how I would show that out. Always show the indeterminate form. Try not to do too much mental math. I mean, I know a lot of you are very good at your mental math, but just make sure you don't make mistakes. All right. Find the absolute minimum value of f on the closed interval from -2 to 8. All right, fundamentals here. I always tell my students, the moment they ask you to find an absolute extrema on a closed interval, you're going to just make a table and include the endpoints. Simple as that. Let your table explain what it is, all right? But first you need to understand, or let the AP grader know, is that f prime equals 0 at what? X equals -1, 2, and 6. Because what you're doing inside the interval is you're telling the AP grader that you know fundamentally a possible critical value occurs when the derivative itself is equal to 0. Now I'm going to even take it further. I'm going to go to -1 and f prime changes from positive to negative. So that's a max. I'm not going to write a big sentence about that. At 2, it's f prime's changing from negative to positive, so that means I know I have a min there. And then at 6, I have neither. That's a false critical. So I'm not going to look at the max. I'm not going to do the neither. And what I'm going to do is I'm going to make myself a table. And I'm going to table it out like this. I need x, and then I need f of x. But I'm going to even let them know that I know it's an accumulation. Now, they didn't give me a rule. They gave me a starting value. So at f of 2, it's 1. So I'm going to go 1 plus the integral from 2 to x of f prime of x dx. That's how I do my accumulation to get to f. Use the starting point, use the area under the curve of my f prime graph after that to kind of figure things out. But that's what I want them to see. Always put in your endpoints into your table for absolute extrema on a closed interval. And then I'm always going to put in any critical values that match what I need. So this is a minimum. I don't need the other ones. I only need to find this one. All right. So at -2, well, this one, well, I'll go left to right. 1 plus the integral from 2 to -2 of f prime of x dx equals 1. Now let's look at this. I got to start at 2 and I need to go backwards, right? So if I'm going backwards, any area below becomes positive, any area above becomes negative. So I'm going left to right. So that's equal to 1. Now I'm going to add the area of this 3 by 2, right? So that's one triangle. So that's 1/2 of or actually I'm gonna only go here because I can see that these two triangles are gonna cancel out visually. So I only need to go to 2 by 2. And it's really plus 0 after that because this piece and this triangle and this triangle are going to net out to a 0 from right to left. So I only need to figure out this area here for this. So that would be 1 plus half of 4 is 2, so that would be 3. And you should know how to do your accumulations geometrically. So to get 2, I need 1 plus the integral from 2 to 2 of f prime of x dx. But when you integrate on top of itself, it's just 0. So that'd just be 1 plus 0 is 1. And then the last piece of the puzzle is to take 1 plus the integral from 2 to 8 of f prime of x dx. All right. So I'm kind of getting into their trademark, but that's okay. So I got to go from 2 to 8. Well, I can go from 2 to 4, but don't forget the 1 starting value. 1 plus, now from 2 to 8, I can get this 2 by 2 area of that triangle. That area is going to be positive because I'm going left to right, and that's above the x-axis for f prime. So that's half of 2 times 2. Now this is where some of the students might have messed up or made a mistake. You're like, well, wait a minute. The half circle's area is up here. I need the area between the curve, right, and the x-axis. Well, just make a big rectangle out of this. This is a what? This is a 4 by 2 rectangle. So that would be 8. And then subtract the area of this half circle, and that'll give you these little pieces here that you need. So what's the radius of that circle is 2, so that would be what? Minus 1/2, because it's a half circle, times pi, times the radius squared. So the radius squared is 4, then times pi. So let's write this down. So that gives me what? 1 plus half of 4 is 2, plus 8 minus 2 pi. Which means that at 8, the function value is actually, what, 11 minus 2 pi? And that's where a lot of students would have an issue there. Just be careful. Just look, think about how you would get that area. Area of the shaded region, right, would be the big rectangle minus that half circle. So now I can answer the question. I'll just answer it here because the table shows all my work and this shows all my work. I'll just answer it now. The absolute maximum value of f, use their words, on the closed interval from -2 to 8 is 1. And again, I'm going to let my table and my initial f prime equals 0 answer it for me. Hopefully that helped.